Okay. Okay, so this is the question. Okay, so that the first person to say it completely. So let's start with the second. Okay, so we aim to deploy a microservice-based application, specifically the sock shop. Yeah, you can unmute your mic and ask question.
Hello, hello, sorry, please, I can't hear anything. Oh, don't know if it is only me.
Yeah, can you guys hear me?
Yes, we can hear you.
We can
Okay,
hear
Yes,
you
we
clearly.
can.
Yes, we can.
you need to check your mic. Yeah. So if we continue with this, you can see we aim to deploy a microservice-based application, specifically the sock shop, using a modern approach that emphasizes automation and efficiency. The goal is to use infrastructure as code for rapid, which in this case is Terraform, right? For rapid and reliable deployment on Kubernetes, right? So the main goal is for us to use Terraform to deploy every single thing on Kubernetes, right? And the setup details explained. What you will do, your main task is to set up the Sockshop application, a demonstration of microservice architecture available on GitHub. You will be using tools and technologies that automate the setup process, ensuring that the application can be deployed quickly and consistently, right? So they want the application to be deployed quickly and consistently, and that's the reason why we're using IAC, which is infrastructure as code, right? So us using infrastructure as code, which is Terraform in this case, we will just need to just run one command and everything is created, and run another command and everything is destroyed. So you see how flexible it is than going into the internet to say you want to create an EKS cluster. You want to first thing you have to first do is to create a VPC, create an EKS cluster, create all the policies you need, create all the rules you need. I guess what I'm saying. Then launch the EKS cloud. I know this kind of thing is just stress. So we're trying to automate the whole process using Terraform. Yeah. And yeah, these are the resources for the sock shop, and this is the demo. This is the first one, so let's open this, and this is the detailed implementation, right, of the sock shop. um, okay, so it's saying this repository has been archived by the owner on December 5th 2023. It is now read only. Okay, so I'm guessing. Okay, so this is the whole microservice for the section. And if we go into the Docker Compose section, because here you can see the command is just Docker Compose. Yep. Okay, so let's check the deployment. Okay, so this is just markdown of the microservice, more explanation of how to use it and different ways. But in this case, we are not using Docker. We are not actually using Docker. So if you look at the second one, yeah, we can see this is exactly how it should look like when you have deployed it, the Sockshop application on your website. And yeah, so if you come to the deploy section, Yeah, so you can see the deploy option. You can either use Docker Compose or Kubernetes. I'm guessing this Docker Compose is basically just for Prometheus, because now you can see Grafana, you can see Alert Manager, you can see Docker Compose on YAML, you can see Prometheus on YAML. So we have to just go back and click on Kubernetes. Okay, let's check this complete slash demo or YAML. So here you can basically see the whole what's it called, the whole code or the whole manifest you basically need to create everything. Now for the cards, which is like the first one you should create, right? It is directly this is the image, with work demo slash cards 0.4.8, right? This is the image, and we yeah, so this is also the service for the card. So this is just, you can see all the images you need here that will basically, and you can see the services that will basically be connecting or talking to each other, right? When you basically look at this very well, you can see all the services that are talking to each other. You can see everything is going to be present here. So this is basically what you, on a normal day, this is what you would have used to craft out or create um the Terraform script. I get what I'm saying, or convert it into Terraform. This is the code you're supposed to use, or this is the manifest you're supposed to use. So yeah, if you come back here, so that's that for the detailed implementation. If we look at the task instructions, we can see they said use infrastructure as code, automate the deployment process. This means all the steps to get the application running on Kubernetes should be scripted and easily executable, right? So this should be easily be executable. That's, we should use infrastructure as code, which is Terraform, to basically deploy every single thing, right? And here it says focus on clarity and maintenance. Your deployment script and your configuration should be easy to understand and maintain. Think of someone else or yourself in the future needing to update or replicate your setup, right? And key evaluation criteria, deployment pipeline. Now, how the application moves from code to a running environment, right? So basically the deployment pipeline basically means Jenkins, right? So how do you basically move the application from just a code and running it using a pipeline to become an environment? This is where Jenkins comes in. Now they said monitoring and alerts, right? Implement Prometheus for monitoring and set up alert manager for alerts. I get to what I'm saying. Implement Prometheus for monitoring, and set up Alert Manager for alerts. So this basically, we're going to be installing Prometheus, which the whole process is still going to come. This basically, the monitoring is basically you installing Prometheus and Grafana. Yeah. And lastly, they said login. Ensure the application operations can be tracked. Yeah. So you need to log every single thing that is basically going on in the application. So in case of any error, you can basically know where it is coming from. So yeah, that is also very helpful. And when we scroll down a little bit, they said ensure the application's operations can be tracked and analyzed through logs, right? So yeah, they basically said the same thing here again. So tools for setup, use either Ansible or Terraform for managing configurations, right? So you can use either Ansible or Terraform. But since we're already using Terraform to create everything and run everything, using Terraform would still be a very good idea. I get to what I'm saying. So they said okay. Okay, so they said choose an infrastructure as a service provider where your Kubernetes cluster will live. And number four, security and HTTPS, right? So now they said make sure the application is accessible over HTTPS by using Let Encrypt for certificates. Consider implementing network security measures and use Ansible Vault for handling sensitive information securely. So now, what is HTTPS? So let's encrypt. So if you come over here to the top, yeah. So this padlock that you're seeing here, right? This is basically what secures the website and basically shows that it's legit. So when you create your own website, it should have this padlock, right? Normally, when you create your website, you should always be seeing an error that this site is not safe or something like that. Anytime you try to launch a website or an application or an EC2 instance that is not secure, you will surely get an error. So this padlock here is basically what Let's Encrypt is, or what your certification is, or what your security or HTTPS is, right? So yeah, and they said use Ansible vault for handling sensitive information securely, and yeah, this is the extra project requirement for bonus points, right? So HTTPS requirements, the application must be securely accessible over HTTPS, same thing they said here, and infrastructure security and enhance security by setting up network perimeter security rules, right? And sensitive information, use Ansible Vault to encrypt sensitive data, adding an extra layer of security, right? So if there is any sensitive data in whatever it is we are doing, we should use Ansible Vault to do that. So the last is the project goal. So this project is about deploying a microservice-based application using automated tools to ensure quick, reliable, and secure deployment on Kubernetes. By focusing on infrastructure as code, you create a reproducible and maintainable deployment process that leverages the modern DevOps practices and tools. So, is there anything here anybody doesn't understand in the whole exam question or in the whole capstone project question? Is there anything that is still unclear? Because now you can see in the question they said we should use certain tools, all right? The first tool they said we should use is Terraform. Terraform for basically writing out the whole code that is going to help us automate everything. They said we should use Jenkins. Jenkins helps us to take Terraform from just the code to becoming an environment. The whole code in Terraform from just the code to becoming an environment. That's where pipeline comes in, right? And we're using Prometheus to basically watch over the whole right for logging and the rest, right? We'll be using Prometheus for that. So, any questions with the capstone question? Okay, give me a minute since there are no questions. Okay, so this whole thing, we're going to be breaking it down, right? Um, into different things. Okay. Okay. Okay, so like I said, we're going to be splitting everything into different days. So for today, we're going to be looking at the EKS cluster. How do we create the EKS cluster, or how is it created? I know most of you have watched the video, right? And might have some questions. Like I said, I'm going to show you a more advanced EKS cluster that you can use for your capstone project. So yeah, let's go into it. So this is for this. Yeah, this is for this, and let's cancel this out. I don't think we'll be needing this also. So yeah, if you come over here to our EKS section, we click on the first, which is the version.tf. This is where we basically write out the provider and the the provider also, right? So yeah, this is where we have it. And also, if you have your credentials in your home section, that is on your machine or wherever, or if it's a remote um, machine that you're using, and you have it in the home directory, you can basically type out the directory here, right? And it can basically use that to um, know your what's it called, your secret key and secret access key, right? And if you go to the second um, layer, which is the generic variables, here we can see the variables for the AWS region, the variables for the environment, and the variables for the business division, right? All these are not really needed, but it will also be really professional if you implement them. Now, if you go to our local values, we can see the owner, we can see the variables also for the business division. That's who we're setting as the owner, and the environment, we're setting it as the variable environment that was basically declared here. And the name, we're also giving it a name of the business division and the environment. So the EKS cluster name also is also going to be the same thing with the var.cluster name. This is also a variable. So yeah, so the common tag also, we have the owner and the environment, the local.owner, local.environment, which is also reflecting back to this owner here and this environment that is here. So when we go over to the VPC variables again, we okay, while it's taking time. Okay, so we check out the variables here. You can see we just stated out all variables here, right? We stated out all the variables here, and we're going to use a TF um, a TF-vars file to basically pass in all the variables. So right, that's the same thing we're doing here. We're just listing out all the whole variables that we'll definitely need, like the VPC enable NAS gateway, the VPC create database subnet route table, and every other thing like that. So when we go to the VPC module, so what we're doing here now is we're not basically creating a VPC, we're basically just pulling a VPC from Terraform, right? Using modules, right? So if you can see, this is the data, and we're basically selecting the availability zones. So we're telling it to exclude names with EU West 2 that dash IA dash LA, right? You should exclude these names. And when we scroll down, we can see the create the VPC Terraform module. Sorry, hope you guys can see my screen.
Yes.
Yes, yes.
Yes, we can
Yeah,
see.
yeah, yeah.
Okay, great. Okay, great. So when you say this, you can see the module here, and this is the source of the module. You can see Terraform AWS module. You can see it's a VPC, and you can see it is AWS, right? So, and the version is 3.19.0. This is the version of the module that are basically pulling, yeah. And you can see the VPC basic details, the name, which is the local name that we are going to be giving it, and the var.vpc name. So you can see everything here is a variable, right? Because we want to make it flexible. We want to um, we want to be able to easily change anything in it, right? So you can see the database subnets when we're creating the database subnets group, the data and creating the database subnets route table. Also, we're seeing the NAT gateway. We're going to be enabling the NAT gateway and single NAT gateway. So the VPC DNS parameters, the VPC tags, the additional tags to subnets, right? And yeah, so all these are just tags, right? They are just tags that are going to be added to the subnet. So this is our VPC module and the VPC output. So now this is what comes out after the VPC is created. What do we want to know when the VPC is created? We want to know the VPC ID, right? We want to know the VPC CIDR block. We also want to know the VPC private subnets, right? We want to know the ID of the private subnet. We want to also know the ID of the public subnet. We also want to know the NAT gateway public IP, right? And we want to know the availability zones, right? We want to know the availability zones that were attached to the VPC when it was created. So now, when we go to version host, right? So I hope you guys know what the version host is. Although we won't be using this, the version host, but well, it is there in case of future use, right? So the version host is something you basically use to when you're trying to log in into a um private subnet or into an instance that is in a private subnet, right? So you know that when you have an instance in a private subnet, it is only an instance that is in the same VPC, right? Is in the same VPC as the instance in the private subnet that can log into that instance, and the instance that is doing the logging in must be in the public subnet. Are you getting what I'm saying? So that's the reason why we have a version host, and that's what the version host is called, right? So for our version, we can see that we are creating the EC2. This is just the variables for the version host. We have our key pair and we have our instance type. When we scroll down, we can see our version security group. Yeah, so this is the security group, which is 0.0.0, which is anywhere. Yeah, probably the most important thing. And we're also using modules to pull this, although we're not using this, we're not using the version notes. That's why you see it's commented out. You can see the source, we're pulling this through modules and we're giving it a version of 4.17, which is at at that time was the latest version for the version notes. So when we go to the IAM data source, so what this does is it helps us to filter out a particular what's it called, a particular image. I get what I'm saying. So if you look at this, it says data aws underscore IAM and the Ubuntu most recent true, which means it should be the most recent image, and the owner, which is this is the Ubuntu owner, right? This is the Ubuntu owner, and I don't know, this also might change depending on your location or the what's it called that you're using, right? So this might change. It's best you go over to your what's it called? Go over to your EC2, right? When you're trying to create an instance, select the Ubuntu and try to check out the owner of the Ubuntu you selected in your specific region, right? And when you can see the filter, we're basically using values for Ubuntu slash image slash HVM slash SSD slash Ubuntu slash focal. So basically, this is the default for the Ubuntu focal that we're going to be selecting, right? And this star basically means anything behind this, it should just help us to select it. We don't care what is behind it, right? So far, this one comes before it, which is Ubuntu image. We want to use that image. That's what I'm saying. And the root device type is also EBS, right? Virtualization type is HVM, and yeah. So this is just like a specification of what we want to use. Yeah. So before you could also do it with other images, right? For instance, this is Amazon Linux 2. Amazon is the owner of this image. Yeah, and you can see other specifications here. So that's what we're going to be using for this. And when we scroll down, we go to the version output. Yeah, so in the version output, we can see the AWS EC2 instance, Terraform output, public EC2 instance, version host, and yeah, we can see the output of the EC2 version public instance IDs, right? And we can see the elastic IP also. And if you go to the next, you can see we are also creating the version host here, the EC2 instance through modules, right? So yeah, most of the things here are basically created using modules. So you can see the module is EC2 version host, the version, the Terraform AWS module, EC2 dash instance AWS, yeah. And yeah, the version host is just like a normal server, right? But the reason why it's called the version host is because it is used to log into the what's called into the private server in the private subnet, right? So this is this, and we also have our elastic IP for the version host. So if you click on that, yeah, so you can see the elastic IP, how it's created, and you can see this, which is one thing I've always wanted to mention. This depends on. So what this means is this: when you see anything that is depends underscore on, it basically means that this service should not create or should not be deployed until these two, right, which is the EC2 version host and the VPC, are deployed, right? So that's what this depends on, mean, right? It is depending on this tool to be created before it is created, right? And that is actually is going to actually be very useful in this project. We are going to see it a lot. So the next, you can now see the version provisionals. You can see the yeah, you can see the connection, the SSH connection. Yeah, you can see the key pair, the source for the key pair. That's if you are imputing a key pair. So this is the private key. This is the key you're supposed to impute here, although we're not using this. And we are going to be changing the we're going to be giving the key pair a source. So this is where the key pair is, right? If it's on our local machine, we want to copy the key pair into the the instance once it is created, and also we want to also change this, right? We want to change the modification, because if you do not change this, it's not going to work, right? So we change it to 400, and yeah, that's all. That's what we're going to be doing here in this version provision. As if you go to the EKS variables.tf, we can see all the variables for our EKS cluster that we're going to be using. So all these things are variables, and if you go to the EKS output, we can see all the outputs that we will also need, right? The cluster ARN, the cluster ID, the certification, the cluster endpoint, cluster version, and all those kind of stuff. So if you go to the IAM row for the EKS cluster, because we need to create two rows, or two rows for the EKS cluster. So yeah, this is the first row, yeah, and this is the second row. This is actually like a policy attachment row. So this helps us attach this to the cluster that we're going to be creating, right? That's basically what this is for, right? And if you also want to create a, what's it called, a row that basically enables security group on your pods, right? So if you want to secure the pods inside the Kubernetes cluster, right? I hope we all know what pods are. So if you want to secure the pods in the using security groups in the security in the Kubernetes cluster, we can basically use this particular kind of what's it called? We can use this particular kind of role. And if you go to the IAM role, the node group, we'll be creating a role for the node group, and you can see the resource, the AWS IAM role, the yeah. So this is the role for the node group, and we're also the same thing we did previously. We want to attach that, and so this is basically for the nodes to communicate with the EKS control panel, and this role is for the node to be able to pull um, containers, or to be able to pull containers, yes, from the Amazon registry, the Elastic Container Registry that's on Amazon, right? So this is the role for that. And if you go to the next EKS cluster, which is um, the next code there, we can see us see how to create the EKS cluster with the row ARN. We have the version, everything variables, everything is variables, and also you see this here too, which is depends on, right, depends on, and this is depending on the EKS cluster policy and the EKS VPC resource controller roles to create before the EKS cluster will be created. Yeah, and the next is going to be node group. Okay, so we want to create our node group. This is basically where we start creating the node group, and you can see the cluster name that we're selecting. You can see the node group name. You can see the node row ARN, which is the one we created here. We're basically just tagging it here, and the modules.vpc, which is our subnet ID. right? We're using the emojis we used to create the VPC. It also helped us create a what's called the subnet. So we're basically tagging that subnet ID, and we have the version here, right? When we scroll down, you can see the AMI. Yeah, so this AMI is the one we're going to be using for our Ubuntu, and you can see the EC2 SSH key here. We can also see the scaling config, which is this the desired size, the max size, and the min size, right? So the desired size is 2. We actually want um machines, or 2 remote machines running on the cluster, right? This is our desired size, right? So this is the maximum size we want. We still want 2, no matter how many people visit our site, right? We still want to keep with the budget, so we still want 2 people now. So if there are now less people visiting the site, we now want to reduce the amount of nodes to 1, right? But this also is not something that's advisable, but we're just doing it because of budget, because of we're all using a free tier application or free tier, right? So we're going to be using 2. Normally you would have increased this to like 5, 6 or so, right? So yeah, and down here you have tags that we're going to be using. Yeah, these are the tags that we're going to be using for the public node group, right? So we also have the private node group, right? But we're not going to be creating any private node group. It's only the public node group we're going to be creating, right? So basically the same thing, right? But now you have to change the subnet to private. Yeah. So when we scroll down to the version auto, right? That's the version host, the TF These are the TF we're supposed to be using, right? The instance key pair and the instance type. But we're not going to be using any of these because we're not using a version host, and we are not using a private subnet also. So yeah, that's that. And also, when we go down to the EKS auto.tfvars, we can now see that we are basically creating values for every single thing that was used as a variable. So for the cluster name, you can change this to your cluster name, right? For the cluster service, and this is also very helpful too, because for those that would want to change certain things, right? You don't just go into the files to start making changes to it and start getting some errors. You can just basically change the cluster name here. You can the IPv4, right? The IPv4 CICD block, right? You can also change it here. And the cluster version, which is 1.24, we have the endpoint. We want to set it as false. The public access, we want to set it as true, and 0.0.0/0. And if you go to terraform.tfvars, yeah, so in the Terraform.tfs, this is where you can now make a change to the AWS region, to the environment, and the business division, right? So now you can put whatever name you want to put here, right? But the AWS region, you know that is always EUS2, right? The environment, you know that it's dev, right? Is a development or production environment. You put it there, right? And the business division, whatever name you want to give this, your choice, either it's Capstone or whatever, you can write it here, right? And if you scroll down, you can see the VPC auto.tfvars. This is now where we now impute all the VPC values, right? So now from here we have the VPC name, which is the melee VPC. You can also change this to whatever name you want to put it to, right? So you have the VPC cider block, and this is a 0.0/0/16 rather. So this is the cider block for the VPC. We have the availability zones, which is AUS2A and AUS2B. We have the VPC public subnet. Yeah, so all these two, they are all basically present here. And we have the enable DNS support true, DNS hostname true, NAT gateway true, enable NAT gateway true, and the database subnet and route table also, they are all set to true. So this is all you need for the Kubernetes. But I'm not going to be running this in this class, right? I'll be running this in the next class, because all these, like I've said before, all these here are most of the what's it called? Most of the code here, or most of the versions here, has been outdated, right? And yeah, you might run into one or two issues. So far, do you guys understand everything I just said? Do you have any questions?
No question for me.
Okay, that's good. Does anybody have any other question?
You have to digest it again before we can come with questions.
You said?
I said we'll still have to digest the video all over again before we can come with questions. The
Okay,
recording.
okay, sure, sure.
Yes, I agree with that.
Um, yeah, so if you have any questions, maybe later on, because since that nobody has any question now, you can always send it to the group. I get what I'm saying. And yeah, in our next class, I'll be making some changes. Like I'll try to run this case poster, and hopefully there's no error. I will send out the what's it called? The um the repo to you guys. Yeah, so you guys can basically try out the EPS poster on your end because this is not anything too serious, right? Only thing you need to do here, right? If I've tested this out and it's working, only thing you just need to do is just do Terraform apply. I get what I'm saying. CD into this EKS poster section and do Terraform apply. So you see the whole reason why our school wanted us to make it reusable and easy to basically use to create and destroy. Just do a Terraform apply. You have created every single thing here. On a normal day, you would have first created the VPC, created the public and the private subnets, scroll down, create the version host, create the EKS cluster, then specify the nodes and every other thing. But you can see how simple Terraform made everything for us. So yeah, I'll check this out and send the updated version to you guys so you can now make changes to where you see fit. Like I said, to the names that are here, right? We can change this name or the environment. If it's a production environment, the business division, if you want to call it Capstone, it's your choice, right? If you also want to change the um yeah, if you want to change the cluster name too, it's also your choice. But I won't really advise you changing the cluster IPv4 CIDR block and the cluster version. Yeah. So so far, do you have any questions again for the last time before this class ends?
Okay, Mentor, can you hear me?
Yeah, even if it's with the whole project. Yeah, you can speak, please.
Okay, I want to confirm, is it only from the EK cluster that we're going to run on this project, or both on that of other session that was given based on the question?
Yeah. Everything is running on the EKS cluster, right? The Prometheus, the what's it called? The Sockshop application, everything is running on the EKS cluster.
Okay.
Yeah. Charles, you can unmute your mic, please.
Sorry, I wanted to ask this repo you used to explain this class is just for educational purposes. Yeah?
The repo I should explain this class.
Yeah, because there was the one in the video is different. It seems like it's different from this one.
Yeah. In our last class, remember I told you that we show you a more advanced EKS cluster. That one that was in the video was something that is very easy, right? I mean, everybody here wants to score 100 over 100, if I'm right. So you want to use something that is more professional, and this EKS cluster basically helps you with that. Hope I've answered the question.
Okay, all right. So in the next class now you would
Yeah, we will
explain
deploy
better.
it. Then we will deploy it in the next class and move on to the Kubernetes section, which we have here. Yeah, so we'll move on to the Kubernetes section and to be explained. Yeah, you can unmute your mic, please. Yeah, I did it.
Yeah, it is.
Good evening.
Yeah, good evening.
Hello. Yes. The weapon that you just explained to us now.
Yeah.
it was given to us by old school in the socks shops. But
Okay,
if we run that repo like that, will it not run?
which repo is that? Is it this EKS one?
Yes,
This one.
yes,
It was given
yes.
to you by old school.
No, I thought
No, no, no,
you.
no, no.
No, no, no. Okay, I can see now. No.
No, this is a
Yeah.
different repository, right? And if
Okay,
you
okay.
run this, you might get some version error, right? Everything here works, right? But the only issue is the version because this was like last year since when it was used or since when it was edited, right? And yeah, you surely run into one or two version issues. But like I said, you can run it and learn by yourself, right? By searching Google and looking for the right version. Yeah,
Okay, thank you. I saw it now.
yeah, you're welcome.
So, mentor, this repo now, this is the same one you share in the platform, right?
You said?
This repo now that you just
Yeah, yeah.
pointed out now, is it the same one you share in the platform?
Okay, what platform is that?
On this WhatsApp group.
Oh, I haven't shared this yet. This hasn't been shared yet. I said I'll look into this and try it out and update it rather. Then I'll send it out.
Okay, no problem.
Yeah, please you can unmute your mic.
All right. Good evening, sir.
Yeah, good evening.
So, so basically, this repo is what we're using now for the project, right?
Yeah, this is the code we're using for the project.
Okay. But I thought you said we'll be explaining everything this tonight. I don't know. Probably that will be possible.
Okay, explain everything as how. Is it the whole
Like, yeah, like the repo on the project.
the repo of the project?
Yes.
That is everything here. Okay, so
Yes. Yes.
Adeni, I said that we will take this step by step, right? I don't want to confuse a lot of people here, right? So we'll be doing this
Okay.
like daily. So our next class, we are going to
Okay.
be looking at the next section, which is the we're going to be looking at a part of the next section, which is the Kubernetes section, right? And we're also going to be running the EKS cluster too in the next class.
Okay. 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 All right. No problem.
Yeah.
I think
Mohammed,
that confusion is
you said what?
um because I think we are seeing this repo for the first time. For me personally, I think
Yeah,
that maybe when we put it together, it make more sense.
yeah. Mohammed, please, you can unmute your mic.
Yeah, yeah, sorry. Mento, I think what Mr. Adeni was saying, I just wanted to, I think this repo here, it's just for the cluster, for the EKS cluster to
Yeah,
deploy it.
the one we explained today is just for the EKS cluster, right?
Yeah, I understand that. This is just the cluster. There is still the Jenkins, there is still the other part. I think this one is just basically for deployment of the EKS cluster and I think that's just what this repo explains, the whole of it.
Yeah.
It's
So,
just
like I said again to Mr. Abini, I said that you we are going to break everything down into different deals. I get what I'm saying because you can't just
yeah, yeah,
focus on everything at
yeah,
once. I get to me. So today was
yeah,
just for the EKS cluster, right? Our next class
yeah.
will be looking at the parts of the what's it called of the Kubernetes section. Rather, we'll start looking into the sock shop application. Yes. Okay. Hope guys understood. Okay, so I'm guessing that's all the questions so far. The recording is going to drop.
When is our next class?
Yeah, the next class is on Tuesday. But before then, you guys will get the EKS cluster. So if you want to run it privately, then sure.
So we have to run them one after the other before, so that we know that it's working before we now do that deployment
Yeah,
from
so the
GitHub.
Jenkins is the last part. The most important thing is to make sure everything works, right? If you can run the EKS cluster manually and you can run everything, which is the Prometheus and the Sockshop manually, then using Jenkins won't be a problem. That's why the Jenkins is kept for the last part. Yeah, you can use it.
Because inside that video, it didn't show
Okay,
how
let
you know.
Femi, let Mr. Femi finish. Yeah, Mr. Femi, say something.
Yeah, I said inside that video, you didn't show how they were going to run it manually. So they were asking you that how are they going to do it with Terraform, because you were using Ansible. So you told them that they needed to run it manually before
Yeah,
pushing to GitHub.
yeah.
Okay.
Okay, Mr. Adini, you can ask the question. Hello, Mr. Adini, are you there? Okay. Does anybody have any other question? Or that's all?
Hello.
Yeah,
Hello, can you hear me?
I can hear you now.
Yeah, Chief, can you hear me?
Yeah.
Okay. Yeah, please, I just want to I want to do we need to edit the repo?
Is it
Like maybe on our own.
the EKS?
The EKS, the like yes.
Okay, so for the EKS, I already mentioned the parts that you can edit. I get what I'm saying. You making changes to any other thing basically means you are trying to do something else. I get it. So yeah, if you want to edit, like I said before, you can change the cluster name, right? You can also make changes to the CIDR block if you want to. That is, if you know what you're doing, and also the cluster version. So you can basically check out the latest version of clusters, right? You can check out the latest version of cluster and you can use that particular version, right? So if you scroll down again for the VPC auto.tf files, you can also see some things there too that you can change the VPC name, you can change the VPC CIDR block, right? If you are using another region, right, you can also change the region. This is EU West 2A. If you are using US Eastern, you can also change the region to US Eastern too, right? So if you go to the terraform.tf vars, the AWS region also, if you're using a different region, you can also state that here. And the environment, you can state if it's a production environment, a development environment, a staging environment, or anyone as the case may be. And the business division, you can state whatever it is here, right? So, yeah, Mr. Aditi, you can use the mic.
Hello, sir. Yes, the 10.0 part, we can't change it to maybe 198. We should leave that.
Okay, is it for the VPC? Yes.
Yes, yes.
Okay, so you can the VPC. It depends, right? If you try any cider block, you can basically just go to Google and search cider blocks you can use for the VPC cider block, or you can ask what's it called, ChatGPT, and it can provide a list of cider blocks you can use. I get what I'm saying. So you can also try that out if you want something different from this.
Okay, thank you.
Yeah, you're welcome. Okay, hope I've answered everybody's question because I have just 4 minutes on this call.
And so that repo now, in that repo now, the code there are working perfectly. I mean,
Is it for this case?
yes.
Okay, so like I said before, it is working perfectly well, but the only problem is most of the or most of what we'll be using there, the versions would have been outdated, so you might get like a okay. Mr. Adeni, can you mute your mic, please? Okay, so like I said before, the codes here, the versions would have been outdated, right? So the only error you'll be getting is outdated version error, right? Every other thing here works perfectly well. That's why I said I would have to check it out and basically look for the latest version before I send the original code to you guys. When I send out the original code, you can decide to run it by yourself. I get what I'm saying.
Okay. But I'll wait.
Okay, okay. Okay, I'm guessing that's all the questions. Okay, so from this point, if you have any question, you can just send it to the group and I'll definitely reply to your question. So yeah, see you in our next class. And if you have any questions, like I said before, send it to the group. So that's the end of this call, this class.